Hi, welcome back to CMG-MathSpace. We are still continuing with our series on the properties of sets operations, how to represent this in a Venn diagram. We have done a number of episodes. I think we have done 3. So this will be the 4th one on the subsection of properties of sets, right? Operations in a Venn diagram. Now, we are continuing and we would like to set some preambles, right? Preambles. Especially if you can see on the screen, we have this, we are illustrating, right? We are illustrating the properties of set operations using Venn diagram, right? There are about 3 more episodes to be done. So the relationship here is A union into B intersection C. Intersection C is equal to into A union B bracket close intersection into bracket A union C. Take this, watch this very carefully, or you can even write it down. We will use it. And then the second one follows with what different operations coming first. So A into A intersection into B union C bracket close all equal to into A intersection B bracket close A union blah blah blah, right? So put this at the back of your mind. Now, I would like us to set some preambles straight, because anytime you have to solve any of these questions, make sure this is at the back of your mind or at the back of your head. Now, so we said earlier that when we are doing this, you should check in order of precedence the brackets. From brackets, we will deal with what? Complement. From complements, we go to unions. Union, we go to intersection, and so forth, and so forth, and so on and so forth. Right, so here I have restructured them again because we are starting with another episode. Here we have, if there are more than one operation or operator involved, we have to take a few more steps to do this. There are some of them we have to rewrite the whole expression into another expression. That will make it easier, right? That will make it easier for us to solve this question very easily and fast. So put this at the back of your mind. I'll be doing this. Now, also check if brackets are involved. If brackets are involved, now let's do some cascading. If brackets are involved, check if complements are there. And then check if unions are there. Check if intersections are there. You understand? Else just go straight and shade them directly. So we have given the precedence. Now there are times that all these are not involved. We don't have brackets. We don't have complements, we don't have unions, we don't have probably intersection, right? Or sometimes we only have the basics with the bracket. When you have this, just solve the bracket first, or just go ahead and then be solving them. So brackets, if there's no bracket, no complement, no union, intersection, all that, just go straight. There are times too they are just straight, so just go ahead and do them. That's what we mean. I'll show you examples. So this episode, we are typically dealing with a situation whereby everything is what? Straightforward, right? We are not involving intersection, we are not involving probably complement, right? So I would say that basically intersection will be part, maybe a union will be part, but we are not dealing with complements, because I see so far that complement is what makes the thing very difficult and cumbersome, very obscured, making it difficult to solve. So with the brackets involved, or maybe the union, they are easy to be solved. But with the brackets involving the complements is what starts with the difficulty. So here we are dealing with the basics, and the moment any difficult aspect of it will only be what? Maybe union or intersection, and then the bracket. So the complement will be dealt with later, and where we also involve the intersections of other 2 sets or 3 sets. So here I'm just going simple, right? I think I'm talking too much. So here, let's say we have been given this expression, right? B into B intersection C. This is as simple as ABC. Just look at B, look at C. Where they intersect, just shade that area. It's as simple as that. Shade that area and go your way. Someone may ask, but shading B intersection C is involving what? A also. So don't worry. Just your focus should be on that particular expression under discussion. Any other set involved, you have done your part. So this is the basics. Now let's go to another expression where we have A union now into B intersection C. You see, now we are climbing some kind of difficulty, but not to worry. Now we said that in order of precedence, what do? We deal with bracket first. No complement here. So if it is bracket, then B intersection C. What is there? So B intersection C is what is in the middle, right? Now after that, let's add the union. The union, we are just adding all the sets involved together. So we assume that we have done A, B intersection C. We have that solution down. Now let's go on to where we add the union. Union, we have told you union is you just adding all the sets under consideration, right? So all the areas of what A will be affected. Then you can also see that all the intersections, that's A, B, and C, have been affected. It's as simple as that. You are done. Don't worry yourself. Now let's go again. We see A union B. A union B, we are taking everything in A, taking everything in B, shade everything. By the time you are done, you realize that C has been affected. Not to worry, you are correct. Move on. So these are the basics. Don't worry yourself overthinking, because there are no complements involved and probably no intersection involved, right? Or no complement involved, no bracket, no nothing involved. You can just go straight and do them, right? So this is it. So A union B, we are shading everything in A, everything in B. When we are done, you realize that this C has been affected. No problem. Here we dealt with the bracket first, B intersection C. We are done. You go your way, and then add the A union. Add it. Now here, there's a form of expression involved, right? So hold on. I'll bring that formula here. So here we are. This is the expression that we were given, right? Now I told you when you have been given such a thing and it looks complicated, you have to rewrite them to make it simpler. So this is also equal to this, right? A union into B intersection C. This is the expression. So the moment you get this, now you can deal with the brackets. Now this is the bracket first. So B intersection C, then add the union. Then you see that we are having the same expression here as there. You see, I hope you are getting the point. Here, the same as here. It's as simple. So you see, they were expressed differently, right? Now let's move on. Take your time, because I'm doing this recording and then the time or not on my part. That's I'm doing this. So now come here again. Now we have B union C. So whole of B, whole of C. Automatically or by default, A will be affected because they have all been intersected. But your concern should be here and here on the expression. Now, last but not the least, we have this one also. We are looking for A intersection into B union C, right? So now let's deal with the bracket first. We have what? B union C, B union C, right? Now hold on. Now once again, I told you this once again is expression that we have learned so far. So this is what we are given: A intersection into B union C. Now let's re-express this again. If you express it again, we have A into A intersection B, or union into A intersection C. Check this, the formula. This is the formula here, right? So expressing them once again, you have separate what? Brackets. Then you start dealing with the bracket first. After bracket, then you add all of them. So that is it. So here, so what do? We look for A intersection B. A intersection B, that's the area. Now we move to what? A intersection C. A intersection C, that's the area. Aren't we done? Then the union is adding them together. It's as simple as that. I think you have gotten the picture. So don't overcomplicate things. Just look at them in simple way, literally, and then you'll be good. So no compliments involved, no any complications. We will see in the next one. Bye for now.